Water systems were also designed for maximum efficiency, without any loss of comfort or convenience for the homeowner. Since 3% of all electrical power in the United States is used to run sewage treatment plants, lack of water efficiency in our homes can mean more pollution and electrical usage hundreds of miles away. Clean water is becoming a limited commodity in our world. Rainwater runoff is usually treated as another waste product, which is carried away by the sewer system, eventually creating more pollution somewhere else. To increase efficiency, this home will use rainwater collected from the roof for flushing the toilet, the cold water line on the washing machine, and for a hose bib in the garden. Hot water and drinking water are obtained from a well on the property. For every inch of rain that falls on 1,000 square feet of roof area, about 600 gallons of water will be collected. Even in the New Mexico desert, with only 8 inches of annual rainfall, there is still enough precipitation to fill a 1,500-gallon tank several times over and store the water for a sunny day.
To find the most cost-effective tank, I did a lot of research as to what was available. Concrete, fiberglass, and steel are just some of the available materials. For my requirements, it turned out that a 1,500-gallon polypropylene septic tank was perfect. They're easy to obtain, they're lightweight, and they cost about 50 cents per gallon of capacity. In addition, the plastic is very easy to drill, and that makes it easy for adding plumbing. A backhoe was hired to dig a hole, and once dug, 2 people could maneuver the cistern into place, thanks to its light weight. By burying the tank, it's protected from freezing in the winter, and the polypropylene will not be damaged by sunlight in the summer. Once the cistern was in the hole, it was just a matter of hooking up the plumbing. The cistern itself is composed of 5 major components. A 4-inch diameter plastic pipe transports the water from all of the downspouts to the cistern. When the tank is filled to capacity, an overflow pipe drains the excess water to a lower part of the yard. A pump line picks up water from the bottom of the tank and carries it to the appropriate water fixtures in the house via a separate plumbing system. The pump and pressure tank are contained within a buried 55-gallon polypropylene drum. 18-inch risers extend the access hatches to ground level. Al is constructing 3 triangular cross braces that will be used to reinforce the cistern walls. Polypropylene tanks are not engineered to go dry. Since a cistern may drain down to near empty between storms, a situation could occur where the tank sides could bow inward from the force of the dirt around it. The braces, which are made out of plastic sewer pipe, should give adequate support with the type of soil that's found on this property. Putting in a little extra work up front to prevent problems down the road is always time well invested. The first few gallons of water coming off the roof is what is most heavily contaminated. It has dirt in it, bird droppings, leaves, whatever. So the first few gallons you want to throw away, so only the cleanest water goes into the cistern itself. This is accomplished by using what is called a roof washer. And in this case, we're using a buried small tank that takes the first few gallons of water off the roof and eliminates that from the cistern itself. The water slowly fills up this tank, backs up the pipe, and only then does it start to flow into the simple sand filter. It is deposited into the filter through a perforated pipe just to distribute heavy loads of water during a downpour. Then it filters and trickles through the sand, is collected by another pipe at the bottom of this small tank, and then is taken to the cistern. A drain line is connected to the roof washer so that the contaminated water in the roof washer can be drained off. You just open up the spigot a little bit and it slowly seeps out and then resets itself for the next storm. When burying an empty tank, there's the risk of distorting and damaging the cistern due to pressure of dirt on the outside. To balance this pressure from the inside, a water truck is used to fill the tank with water at the same rate that the dirt is being added to the outside. The added bonus is that there's now a full tank of water on the property that we can use during construction. This will be a big help since the well for drinking water will not be drilled until much later in the project, and at this point the metal roof has not been installed on the home, so therefore there's no way to really collect an adequate amount of water.
When the house is finished and the landscaping is in place, the cistern cannot be seen, since it is completely buried underground. Only the access hatch is visible. With the lid removed, the cistern's water level can be checked, general maintenance can be performed, and the tank can be cleaned every few years if needed. Because of the relatively low underground temperature, the water stays cool and fresh. The 55-gallon drum that contains the pressure tank and pump is also out of sight. A flagstone lid allows access when needed. The entire assembly, both the pressure tank and the pump, can be easily lifted out of the drum for maintenance. Flexible hose connections also allow for easy removal of the unit. A small 24-volt DC pump supplies water to the home through a separate plumbing system, putting out enough pressure to accommodate one fixture at a time. The blue pressure tank stores water at about 40 psi, so that the pump does not turn on every time a fixture is used. Pumping drinkable water through a municipal water system, or even from a well, requires a vast amount of electricity, which is particularly wasteful when one takes into account that most of this water will be used for non-potable purposes and ultimately end up in the sewer. Saving drinkable water for its intended purpose makes much more sense than using it to flush a toilet.